Okay, the word tangent. You've heard it before. When?
Circles.
In circles. And what was the definition of a tangent line in a circle?
Touches something only one point.
Okay, it touches the circle only once. Okay? We are going to work with tangent lines, but with curves. Okay? And it has the same definition. Okay? It is a line that touches our curve once. Okay? Why are we working with tangent lines? Okay? A tangent line is actually used to determine the rate at which a graph is rising or falling at a single point. Okay? What's the rate that we are rising or falling at a single point? Man, what does that sound like? It sounds like slope, doesn't it? Okay? Now, word's right there. I didn't know it was on the slide. A line has constant slope. Do you agree? Okay. Any other function besides maybe an absolute value? Okay. Any other function, we do not have what we call a constant slope. Okay? But what we can find is the slope at a particular point. Just at this point, the slope is this. At this point, the slope is this. And those constant slopes change to create your curve. Okay? So first of all, make sure you understand what a tangent line looks like. Okay? It touches our graph once. Okay? Like this right here. Okay? Not this. It doesn't go through it. It just touches it. Okay? And I want you to kind of imagine that it's, approximating the slope at that point. Okay? That'll help you when you're visualizing it. Okay? So what does this have to do with anything that we've been doing? I will. Here I have what we call a secant line, because it goes through twice, right? Here I have x. Here's the point x, f of x, right? F of x describes the height, right? Okay. Then here is x plus h. And so our function height is f of x plus h. Okay? Now, what is this? That is the difference quotient, right? Okay. So I have these 2 points on my curve. And we're taking the limit as h approaches 0. What does that mean in this picture? What are we doing with our points? We're bringing them closer together. Okay? So as we approach 0, what's happening?
We're getting positive from the slope change.
And it's becoming our
Tangent line.
tangent line.
Whoa!
As we approach 0, that secant line is becoming our tangent line. And our tangent line is approximating, or is giving us our slope at that point. Okay? So here's the same picture. I just gave you a better one, okay? The limit of the difference quotient is giving us our slope. Because basically, this is taking our tangent line Well, it's creating that tangent line, giving us that slope. Okay. We know how to find the slope of a line. Okay? And a line has the same slope everywhere. But if I were to give you a cubic function or a parabola, okay, you would have to find it at a particular point using the limit of the difference point. Okay. So, does everyone understand okay? Why it's giving us a slope? All right, so here's an example of a problem you could see tonight and maybe on Wednesday. Find the slope of a graph at the given point. So here we have our function, and here we have the point in which we want to find our slope. Okay? So first of all, we know that our slope is the same as the limits of the difference point, right? So the first thing we need to do is actually evaluate this limit. All right? So f of x plus h.
X plus h squared minus x squared, so it's going to be
Okay. Minus f of x
x squared
all over h. All right. So now we need to simplify that. X plus h, the quantity squared.
x plus x squared plus 2h x h, yeah, that's the plus h squared.
F of x plus h. I plug x plus h into my function.
Cancel factor, cancel.
Yeah.
All together.
Okay. So our x squareds cancel. And then we need to factor out an h so we can get it to cancel downstairs. And our slope is 2x. We have to evaluate the limit as h approaches 0, so 0 gets plugged in for h and we're left with 2x. That's our answer, sorry. Okay? So I now have an equation for my slope. Okay? Remember, our slope is different at every point. Okay? So if I want the slope, I'm going to teach you a little bit of notation here. The slope evaluated, that's what that flag means, evaluated. What was our point? Negative 2, 4 is 2x. So 2 times our x, which is negative 4. This notation right here is our slope. This means evaluated, and this little subscript tells you where you're evaluating. So I'm evaluating the slope at this point. Okay, let's think about what this looks like.
First, 4,
16.
Sure. And it would be, so you don't use the y, it's just x value.
Well, for this, only the x value was important. Correct.
So hang on, so at 4 times 16, slope would be negative 8.
At 4, 16, our slope would be 2 times 4, which would be 8. Yes. So you can use this to find the slope anywhere. All right? Now let's think about our graph. Oh, those are good questions. Okay, so here's our point, negative 2, 4. And here would be the tangent line. Does negative 4 for a slope seem reasonable?
Close, yeah.
Yeah. I mean, it's pretty steep.
I just want you to draw their line.
Here's our next example. Okay, so it's asking us to find a formula for the slope of the graph, then use it to find the slope at two different points. Okay, so what does it mean, find a formula for the slope? We have to take the limit of the difference quotient. Okay, so let's go ahead and do that. F of x plus h. One over x plus h plus 2 minus f of x all over h. Huh. This looks familiar. This was one of your homework problems that we actually did on the board, right? Okay? However, for the people at home today, we're going to have to go ahead and go through this. Okay? Okay? So, upstairs we need a common denominator. So, our first fraction needs an x plus 2. Minus our second fraction needs an x plus h plus 2. Okay, remember you have to write the limit every time until you actually plug that value in. Okay, I know it's annoying, but sorry. When we subtract these two up here, we have x plus 2 minus the quantity x plus h plus 2. So we're left with negative h. Okay. Then what did we do from here? Okay, we multiplied by the reciprocal, so we were left with negative 1 over x plus 2 times x plus h plus 2. We can finally evaluate the limit. Remember, we're plugging 0 in for this variable h. And so we're left with negative 1 over x plus 2. Very good. So here's our formula for the slope. Now, we want to evaluate the slope at the point 0, 1/2. Do you agree? Negative 1/4? Okay. We also want to evaluate the slope at negative 1/1. Negative 1? So when it asks for slope, you take the limit of the difference quotient. Okay. When you take the limit of the difference quotient, unless it is a line, you will get something in terms of x. Okay. What if it is a line? you should get a constant, and you should probably know what that constant is going to be, right? Okay? This example we did on the board, we have 3x minus 1. We know that our slope is 3. What did we get for the limit of the difference quotient? 3. Okay? So unless it's a line, you are going to get something in terms of x when you take the limit of the difference quotient. That's your formula for your slope, and then you can plug the points in to find the slope at that particular point. Okay, it's always changing, and so this just gives you how to find the slope since it's always different. Alright? Not so bad? Okay? Please make sure you're writing the limit every time until you actually plug it in. Okay? That bothers me.